My angle on social networking is going to be from the standpoint of our society at large. The title here is Semantic Technology Solutions for Gov 2.0, and with an emphasis on citizen-friendly approaches to recovery.gov and data.gov, which are initiatives from the White House, focusing on transparency, openness, and collaboration. We're going to post up the slides. This is the obligatory Hughes Mills. This is one of the areas, the hats that we wear is industry research, looking into the technologies, markets, business models. We do a lot of work with companies, as well as the work that Brand and I do supporting communities of practice and communities of interest who are working in collaborative ways. The basic topics for today. Okay, I'm going to kind of breeze through some slides, and then I'm going to slow down for some others, and then I'm going to kind of dive down to something more practical in the form of some demo slides from Cambridge Semantics. First thing we'll talk about is where the semantic technology and the next internet are taking us. And I'll kind of make four broad kind of categories of points, and then back them up with some of my takes on where things are headed or where things are at right now. The second area is going to be just talk a bit about the Obama administration and the directives towards transparency, openness, and collaboration, which of course have been enunciated since virtually day one. Then I'm going to switch into how we can exploit cloud computing, or how we're planning to exploit cloud computing, Web 2.0 and Web 3.0. So we're mashing up technologies now to support building these citizen-friendly approaches to recovery.gov and data.gov, and I'll explain what I mean about that. And then we'll drop into an initial example of one of these demos based on using Cambridge Semantics NCOR. And the bottom line is that we're at a time now where the semantic community, the semantic technology crowd, can add significantly to government initiatives. And so I will end it all with a call to action. Okay, Web 3.0, semantic technologies, the next internet, where is it all going? So here are kind of the topics we're about to go through. We're going to sort of take a kind of a big picture kind of view, and then drop in and sort of look at some aspects of it. And there's going to be more on the screen than than I'm going to delve into tonight. But it'll be for those of you who haven't seen these slides before, you'll find when you get the deck, you can kind of peruse them at your leisure. Basically, the first thing, the evolution of the internet. I look at it from the standpoint of four kind of growth stages. These things kind of go on in parallel, but the door kind of closes down in certain orders. And basically the four growth stages: Web 1, 2, 3, 4. Not that there's any magic in numbers, but it just is a kind of a way of designating. But the basic axis of evolution that we're kind of looking at here is kind of from left to right is the increasing socialness of it. From kind of wasn't too social, just sort of connected information to people, and by the time you hit the ubiquitous web, before it's an internet of services and things and so on. And then the vertical axis is how smart I am, or the axis of distributed intelligence, and increasing knowledge, connectivity, and reasoning strength. And so that we see, the shift from the web to the semantic web, and from the semantic web to a web of, let's say, smart, agent-oriented, highly granular, but yet collaborative. An example of that was when Eric Schmidt from Google was asked, well, what do you think Web 3.0 means to Google? And he started talking, and it was really kind of fun, because it sort of sounded like an Apple commercial in a way, but he sits on the board, so I guess maybe that's part of it. But he was sort of basically saying, well, everything you're going to want to know about is going to be in the web somewhere. And probably the software you're going to get is going to be more like little apps or little things. Some of them your friends will send you, and they kind of work together and they combine. And so it was a very kind of widgets, intelligent widgets kind of view of things, and I thought that was kind of interesting. All right. Well, anyway, what are some of these characteristics of the next internet, the internet we're moving into? And the internet we're moving into is, by the way, got some serious bucks behind it. Multi-billion-dollar initiatives in Europe and Asia, the United States too. for future internet. I mean, there's the obligatory on the left-hand side, it's like an elephant, different blind people see different things depending on where they pat the little thing, the pachyderm. And, but the basic key thoughts, Internet of Services, the virtualization of infrastructures, i.e. cloud, Internet of Things, emergency of 3D. I mean, one of the key things too is as you get more bandwidth, the world changes. And part of that bandwidth is going to be, these massive, kind of touch screen kind of environments for collaboration. But the other aspect of bandwidth is going to be in the area of reasoning. And finally, in the lower right, XaaS, everything as a service, from software, platform, processes, and so on. So those are the kind of things. The technologies that are shaping this, I say basically are the key ways of looking at it from the angle of cloud computing or the instancing of storage process functionality, Web 2.0, Web 3, and these are the areas that we're going to talk about. But backing up, we're in a transition, looking at this as a kind of a medium for human expression and social organization. We're moving from analog to digital media to social media to concept-based network knowledge computation. And I sort of came up with this phrase because I was talking to a group of people in the scientific, technical, medical publishing area who've been basically thinking about ontology as a subject matter organization, and the real action is increasingly moving in the direction of executable knowledge, or putting the theory into the computer such that you can simulate and test in tandem with experimentation and so on. So cloud computing, just, here's a set of slides on that. It's about scale, it's about complexity. There are categories of clouds. In the center here, there's kind of a piece on where semantics plays in that. But it all rests on, it's still the frontier of this space. It ain't settled out yet. But there's a reason why we're moving in this direction, and the illustration is in the slides on the bottom, is that there are actually some clear business cases in terms of your ability to instance, the basic thoughts at the top. It's scalable, it's on demand, click and run, pay by the drink. There are resources and services that we provision over the internet. Web 2.0, I think you all know, the web of participation. I won't go into the recount of Tim O'Reilly's points. But the basic elements of Web 2.0, user experience, rich media, social computing, collaboration, as well as the web as a platform kind of notion. Some of the key ideas behind web as a platform, it's providing a sandbox, making the data and the users kings, but there are some basic concepts in terms of what Web 2 is about. There's a kind of an architecture from the front end to the back end. That Google's work, and which became Hadoop, and MapReduce and Lucene and these kinds of things, where we have a particular kind of architecture, which is, I would say, is web service-oriented architecture, and a fairly standard kind of set of ways of doing that, in which now the more RESTful approaches, I think, are coming into the ascendancy. And there's some basic approaches to business models in the lower right, that are part of this. When we go to Web 3, or the semantic stage, we're now kind of moving in the direction of a web of meanings and connected knowledge. And lots of things I could say, but the big ticket item is that while we're thinking a lot about linked data today, it's also that we're moving in the direction of architectures of learning and architectures of knowing over and above architectures of social participation and perpetual beta. And I think this is kind of important. Now, when I talk about semantic technologies, I'm sort of looking at how we use tools and methods that represent knowledge about something, for all the different kinds of knowledge you can think of, separately from artifacts, such as documents, data, and program code, for purposes of computing. It isn't that knowledge has been in computers. It has. We've done it, in one way or another anyway. What we're now talking about are knowledge structures, like a kind of a data structure that represents meanings, associations, and theories, and know-how about the uses of things, and so on. And this is what we're giving the name ontologies, small o. Ontologies seem to come in two themes, two flavors. The more or less fixed ontologies are relatively static. These tend to be the ones that humans can actually design. Dynamic technologies, however, have evolving requirements. If we think of a general ledger as a kind of an ontology, that doesn't change but maybe once a year. When we start thinking about linking and making sense of a lot of different information over the internet, presenting results in dynamic ways based on the context or what we're observing as somebody, say, with a mobile device moving through the world, then this is a different kind of game. Point being on Web 2 and Web 3 is that both can process fixed ontologies. And if you've got established enterprise applications that have been well solved, there's probably not much point in redoing them as a semantic technology application unless you have some other things you need to accomplish. But when you're talking about dynamic or changing knowledge structures, then the idea is use the right tool for the job, and semantic technologies are what's about. Fast forward to recovery.gov and data.gov. Because of the dynamics of this, because of the amount and kinds of information that we want to pull together, because of the context of use and so on, this is more like the making sense of the net problem. It is a dynamic problem. It's one where semantic technologies add a lot of value. Now, speaking of value, the value space, I sort of break it out into 4 areas. The capabilities that you couldn't do before, the user experience that if you don't make a change in that, there's no reason for the world to suck your stuff into the web or into the marketplace, let's put it that way. Performance, we've been doing research to kind of nail down gains in efficiency, effectiveness, strategic kind of edge kind of thing, and life cycle economics. Now, I'm not going to go into a business value wrap tonight, but basically what I did want to kind of just sort of point out is that the fundamental longer-term picture on semantic technologies is why we want them, is that they tap a new kind of value by modeling knowledge, by adding intelligence, and by enabling learning by people, learning by systems. And these are a bunch of little pictures that are real fun. Now, does semantic computing at web scale apply to more than government? Sure. Recently, Brand and I have been kind of looking at what's been going on. Others, I think, in the room have probably been involved with what's happening in IARPA with Black Book 2, which is a basically open source based, but it's an environment for analysts, intelligence analysts, to be able to combine and mash up public and private data and at web scale and make annotations and reason over it and so on. And so those diagrams to the right are about that. There are other kind of notions about where we're going with large-scale collaborative and very intelligent environments, the ASpaceX, which you might want to take a look at some point. What's intriguing is that while we're going at this at the level of our advanced research and intelligence, I got a feeling that this is kind of the future of video games, but and probably is going to happen at the consumer end of the market as well. The lower right is the LARKC, which is for massive reasoning across the internet, a major project out of the EU. And even in our country, guys like Mark Greaves at Vulcan and so on these guys are very committed to a whole different paradigm from just the kind of the set theoretic kind of reasoning where everything wants to have closure. They're sort of saying, well, what if there is no right ontology or no one ontology for all things on the web, but rather there are many, many, many kinds of ways. Now, how do we organize to handle that? Well, there's a path from search to knowing, which goes and sort of says if you have more expressive knowledge representation, it'll enable more powerful reasoning. And so the path is from recovery or just basic retrieval to discovery of being able to kind of extract or find concepts, to intelligence, which is to put them into context and patterns, to question answering, which is to be able to actually reason from questions to assemble the information and evidence to make an assertion, to the area of smart behaviors. And all of these things, there are different kinds of modeling and so on. And so the world we're moving into is one not just of just semantic web kind of description logic kind of things, but a whole range of things that go from what we've been doing with folksonomies at one end of the spectrum to very higher order logics and axiologies and reasoning about values and so on. Applications coming. The big thing right now is linked data. Because it's simple, it's doable, and by God, when it comes to recovery.gov and data.gov, we're going to lean on this like you can't believe. But there's lots of other stuff, that's about to happen too. Now, another thing in the semantic technologies is they're enabling collaboration, but it's like collective knowledge systems direction is going. Here I'm illustrating it with MediaWiki and its progressive extensions. From MediaWiki as a read-write space to semantic MediaWiki with its RDF for DPpedia, dealing with linked data, to semantic MediaWiki plus SMW plus, which is Vulkan-funded enterprise largely developed, which allows desktop import of things as ontology management. It can do semantic-based template kind of things, which means you get faceted kinds of search and other things, and semantic apps like semi-intelligent project management systems. Next stage, goes to future semantic wikis, where they're dealing with natural language transsemiotics, by which I mean we're looking at environments where people who encode ideas differently. Some people write code, some people write manuals, some people draw diagrams, some people do a dance. But the point is that what we want is a computing environment that can work with these different forms and representations of our knowledge interchangeably in ways that the different people can deal with what they're strong at, but also the stuff underneath is being resolved and harmonized between. Also, multilingual is another big area getting attention. So issues of machine learning, multi-agent apps, and so on are the next kind of stage of things. And the next stage of things takes the form of different kinds of applications. I say STM because I forgot to change the slide. But next generation semantic applications, ontology-driven, declarative, active, immersive, dynamic, and smarter. And the examples here is decision support, moving from knowledge-centric to, from document-centric to knowledge-centric kind of engineering, which goes from virtual to reality. In silico science in the lower left, other kinds of large-scale simulation and so on. A lot of work in these areas. But beyond the kind of Web 3 stage, is we're moving in the direction of a web of connected intelligences and so on. And one of the key things driving us that way is cell phones. By 2017, 7 billion people all got with IP connection, living in dynamic worlds where we want to be able to figure, your devices are in constant dialogue with stuff that's going around. No way you can do that with today's internet kind of technology. We're too fixed, structured, oriented in the way we build it. That's why we're building the next generation thing. So the web of services, the web of things, and so on, requires a world where things are easy to create, they're self-describing, they're context-aware, and that the intelligent physical world is communicating with us. We're in a dialogue not only amongst ourselves, but with our devices and things and RFIDs and so on. What does all this have to do with the Obama administration, and why are people who are dealing with semantic technologies needed at this point in time to step up and start showing how to address the kind of issues? And basically, the Obama administration came in, and by January 29th, they'd issued a memo that laid out their intent to create directives for a great increase in the level of openness in government. And so the commitment was to transparency, openness, collaboration, participation. And this slide, I won't go into a lot of detail, but government should be transparent, had to do with making the information available, being able to stake things out. Executive departments and agencies should be harnessing new technology to put information in their operations and decisions online and make them readily available. Government should be participatory. Citizens should be interacting and so on. And in this, you see, there's a shift in paradigm. Brandon and I, went through a process when they were doing the DRM, the data reference model, as part of the federal enterprise architecture, where the first time they went through it, they did the usual thing of lock a few heads in a room, and they worked on it, and they came out and they threw it out to everybody, and everybody pushed back and said, no, my requirements are not there. No, I don't accept this. The second time through, it was done in the wiki way, in a collaborative social process kind of way. Took a little bit of time. But there was a core group of steering at 3, and everybody who was a stakeholder, had at least themselves and their contractors and so on at the table. The 23 or whatever agencies were there, and a larger community of at least 600 of people who were interacting, participating in the workshops, commenting on things as they were being involved. The net result is when you got to the end of the trail and that, while it ain't perfect, it was policy that could be stood up, that everybody had already had a chance to complain and, moan about what they didn't like, but the spaghetti thrown against the wall that time, stayed and was usable. We now actually have an administration that actually gets this and, and also sees the advantage in these lighter weight Web 2 technologies and so on. So government should be collaborative, government should be participatory. These things imply also changes in concepts of operation, how you structure the cycle of events that take place. So anyway, kind of key, compare, contrast, in the era of connected governance, what was the industrial era versus the digital era. I'm not going to go into this, but, it's a kind of it was a good thing. This is a Don Tapscott slide. But there are 4 or 5 kind of key differences. There are new models and ecosystems for engagement. You notice that Obama has created, a role of someone for government, for engagement, his office in the office of the president. So we have basically we have connection, engagement, and resourcing. Again, done in a much more extroverted and open way. 2, collaboration and innovation, problem solving. We just had, for an example of this was just the other week, there was a national dialogue on IT for government, and people were solicited to do ideas and comment on each other and do whatever. I think there were close to 500 ideas submitted. There were 2,000-3,000 people that weighed in on it. And we did a thing on semantic, others did other kinds of things, and we all kind of wove it together. But the point was, there are always more good there's more intelligence out there, and there's going to be in your organization, and if you can tap it. Communication, interaction, service delivery. Using blogs, using social media, Twitter, Facebook. Who cares? Also, being again proactive, getting people to interact with things earlier and on, and the enablers underneath all this. New approaches to policy making and governance, but the enablers under it are going to be this kind of use of technology. Also, people have been pointing out there's some principles of open government data. It's open if it's complete, if it's primary, it's timely, accessible, machine processable, non-discriminatory, non-proprietary, and as much as possible license-free. And so there's some definitions, from this. This was from resource.org. So, again, one can argue a couple of those points or want to shade them different ways. But now I want to go, so we have this direction that we're moving to make the information available to, when we're spending the stimulus monies, to be able to account for it front to back and, be able to assess whether or not we're getting our money's worth. Do that with an unprecedented degree of openness, and that we're also looking to change the patterns of how we make rules and regulations and how we conduct the affairs of government to be more participatory, more inclusive, and so on. That obviously requires back-end changes over time, but it also has a lot to do with front-end changes. So how can we exploit cloud computing, Web 2, Web 3, semantic technologies to build, and I'm going to say citizen-friendly, recovery.gov and data.gov. Recovery.gov, by the way, does anybody not know what recovery.gov is about? Is that a scratch? Okay, and data.gov is, of course, about making the information available. Recovery is about accounting for or reporting back on the stimulus funds and how they've been used. Okay, so here are the kind of questions I want to go through. What we mean by citizen-friendly, what sort of computing environment do we envision, delivering this friendly, approach? How do we combine Web 2 and 3? And then I want to talk about people who are partnering with this, and then I want to, go into some demonstration. What do we mean by citizen-friendly? I think it's friendly if we can provide timely, simple, open access to relevant information that citizens can easily both consume and contribute to and mash up with other data sources. So my model of the citizen here, kind of has 2 kind of roles that are critical. The citizen can also be an organization. The consumer point, like what information's there or what apps have been done on that information. I want to search, navigate, discover. I want to read the content and learn about things. I also want to comment and write. Like you can't write you can't talk back to recovery.gov. I mean, we should be able to, post up and, get our digs in. And we want to explore and download apps. I mean, in the back of my mind, I'm thinking, I love my iPhone and I love going to the App Store, and now everybody else is trying to build an App Store too. But the point being is that, there are people who are going to be putting things together. There are lots of different sources besides the ones we'll find in recovery.gov that we're going to use. We'll talk more about that in a little bit. So the other role is a contributor. Brad and I have been doing some basic, very, very, very basic kind of federal data.gov things. And what Brand's been doing is like taking things like, say, something like statistical abstract. And you post up a document, you post up the files or the data sources that are with that, you post up, whatever other kind of metadata or descriptive information. So there's a kind of a wiki function. People can annotate and add to that. So there's this notion of several things. One is the content. Two is exposing the data. And from our perspective, exposing the data, in a way that's semantically, but more importantly, exposing it to a fabric. And by a fabric, I mean it's not just the data semantics here. It's fabric implies that we're laying over descriptions, over more than one thing that we can then mesh together, like a fabric. But the fabric in this sense also includes things like metadata, provenance, access methods, as well as the actual content. Then being able to do the analysis and mashup and do that easily, whether it's on a particular data set or combining different data sets. Then be able to see the results and have ways of doing this. And the less programming, the better. And one of the things we can bring to bear with semantic technology is a lot less programming than before. And to be able to put out the results of having done something interesting in a form other people can consume. Let's call them apps. So we're looking at that kind of citizen-friendly. What kind of a computing environment do we see that being about? Okay, so on the left we have contributo. Okay, so we have the kind of roles of the citizen. The backdrop of this is going to be computing infrastructure that combines cloud, for instance, and other kind of, storage, processing, and computing instance scaling. Web 2 approaches, because they're pretty stable in some areas and becoming quite good, and Web 3. And I'll talk about how we combine those specifically in a minute. And then tools and services, and there's a set of these. They're desktop tools, we want to lean on what we already know. There's kind of web top, wiki, read, write, upload, versioning, web service. They're fabric tools, to be able to expose and edit things like data semantics, the access and provenance, the process semantics of services or extensions or tools or apps, and external knowledge models or domain models that we want to bring in. And so this is the second area. Third area. Then the semantic search, query, navigation, discovery. Some of that is laying over structured information where we know basic kind of categories and things. Some of the things are going to be based on pulling much more nuanced kind of things through natural language. Semantic tools then to filter and merge and extract and mash up with other data and visualize and so on using semantic lenses. And so this existing fabric here shown, kind of on the right, overlays multiple data sources shown here. So our approach on this thing is, no, I don't want to build a warehouse. I want to let the data be where it is. I want to expose it semantically. I want to process the fabric. I want to be able to work with it on my desktop, on the web top, interchangeably. So what we're going to illustrate tonight in the demo is a little bit about how that actually can happen. And what I'm going to talk about now is like some of the people that we're working with in the near term, but we're hoping to join up with some of our other folks. So we got 4 companies we're working with right now: MindTouch, Cambridge Semantics, Zadril, Expert Systems. Each of these guys have different kind of capabilities in what they do. Any one of them has a product that, and they got value propositions independent of each other. But what we're going to be doing in the course of these demonstrations is basically, leveraging these together. So MindTouch is this, and I'm giving you the links and so on, so you'll have it. Is basically a distributed Web 2.0 environment where you can bring together applications, you have wiki capabilities and all of this. It's pretty robust. Everything I showed you on the preceding page. The next one is Cambridge Semantics, and this is the one we're going to show you at least a short demo of in a little bit here. And and with Cambridge Semantics, they have ability to basically expose the semantics of data sets, whether it's a spreadsheet or a relational database, to be able to work with those in a fabric, to be able to combine them and mash them up, be able to do different things. We're going to go into that. But the point is they cover some of the squares, not all of the squares. Zagil, how many people saw the Zagil presentation last month? It's just a few, right? Their pony has a slightly different trick to it. Whereas the sweet spot for Cambridge Semantics is conversations with data. And so getting the metadata and faceted and filtering and doing different kinds of things, visualizing in different ways. What Zagil's been doing is more focusing on the semantics of applications. In other words, what does this application think it knows about requirements gathering? What does this application think it knows about scheduling? Their use case that they started with was software engineering. And so using a set of applications that didn't necessarily know about each other, but what if they could? And you can make them bi-directional in terms of that by using, again, a fabric, a knowledge model in the middle. And so what that allows you to do is to have kind of structured data entry in one or more applications that ties to the model so that everything can be kept synced up. It's kind of gluing these apps together. And so they do that. They also are able to do that, capture the semantics of processes and so on. So that ability to think in terms of looking more deeply at the process, say, of knowledge work, this whole area of transparency, openness, and collaboration, where you want to be able to tie together different processes into your collaborative space. So they've got capabilities there that are quite interesting. So who's partnering to build demonstrations here? Expert System. The Expert System is one of the we heard mention of Calais, Thomson Reuters, but Expert System is probably one of the leaders in doing semantic search-related technology. In Twine, the collaborative environment for interest tracking, they do all of the auto tagging and all of the auto ontology management in that. For BlackBerry's, the help system that you have on a BlackBerry where you do question answering is powered by their technology. They do a number of things where auto categorization and semantic search. By themselves, there's whole opportunities, that could be, for taking semantic search, adding it, say, to a website with a lot of content to ratchet up the experience of how you can, get value from that. But in tandem with these other capabilities, which are working with the more structured data aspects of things, then you start saying, well, if I had a template, and I knew I had the template, this was all about what the product does, but there's like 3 paragraphs here. What was in that description? So then you use something like Expert System and these kinds of technologies to dig that out. So the net of this is you have the ability to cover the space. The only area that I haven't really specifically addressed is in the upper left over there, which is security, which requires a little bit more local context, because mostly people want to basically bridge together piecemeal security systems that they already have. So I'm going to switch now and go to a demo, and just as the setup for it, if I sort of said, what's a semantic scenario for citizen-friendly recovery.gov and data.gov? And I sort of said, okay, 7 points. One is that we want to author, collect, report, when we get the information. We want to be able to do that with tools that also semantically enable. If Google, for Christ's sake, can put RDFA next to content results, why can't I have a word processor that does the same thing with my text? It's that kind of world we're moving in. So Cambridge Semantics and people like that can take a spreadsheet, treat it like it was, RDFA. You don't have to know RDFA. It's just you got the structure of this thing exposed. Okay, second thing is expose this data to Fabric. That's said, keep the data where it is. Get the information you need to work with it virtually, and to know who did what and so on. That means you want information, not just the data, but you definitely want the data and the knowledge about it. Now link and weave the fabric. In other words, if you're going to mash up things from one to another, the ability to tie the things together. Extract, filter, and mash things up. yeah, I only want to see this data, or I want to do this, and tie these things together, and then have a repertoire of ways that that you can visualize and present results. Check. Then I want to be able to package up results in ways that just anybody who doesn't know anything can use if they want to, and make it very friendly, and have a way of managing that kind of environment, and give people the ability to discover, download, and use apps. Back to round one. If they had something like this, you'd have an environment where a lot of people could people could use it, people can contribute to it, and you'd have a disciplined kind of environment in which people who were presenting information or exposing it would be telling you kind of what the data meant at the same time, in a way that make it a lot easier to tie these things together and make it much more scalable. Okay, so let's take a look at a kind of a practical application of this, courtesy of Cambridge Semantics. We're going to say applying their approach to recovery.gov. Okay, so the basic idea is that data is helpful. There's a lot of good data in recovery.gov, but it has a limits. If there's data in multiple sources that you need, or if you have answers that require data comes from outside of recovery.gov, and most interesting questions do. I mean, they were talking today about having 150,000 jobs created, and everybody said, huh? How would you verify that? You don't have, job data from there. You get job data from job data banks from states, and you get information from census and so on. So, the request volume outstrips recovery of people, so you need some ability to work outside, and work on your own desktop. Semantic technology is good for these things. And it basically, allows you to link the sources to a fabric, provide access to these tools, and do the following things, and also basically allow things to be viewed by anyone regardless of technical capability. Okay, so today's question is there a correlation between geographic distribution of recovery dollars, population, and new jobs created? Question. How would you answer that? Well, unfortunately, you'd need to know, recovery spending by state, population by state, new jobs by state. So some stuff, you'd get from recovery.gov, and other things you wouldn't. In fact, the answers live in three sources. Recovery.gov, you'd need financial activity reports and so on. You'd get information from the Census Bureau, and here comes Census Bureau data. You'd need information from the DPC, that reports, the states, their job creation. And the other thing is, so you'd like to be able to pull all this stuff together, and you'd like to be able to see it however you want to see it. Now, in this case, you're looking at a map that state by state is showing you, the jobs created, how big the circle, and then, but this is information that's come from different things. But you might also want to look at it, in this case is one of these kind of, hierarchy maps where the size of the square is how big it is, and you arrange it according to the funding allocation amounts to achieve that. And how are these multiple visualizations and these linking of sources done? Well, in their world, it's done by, one, you leave the data where it lives, you link the source data, and you're exposing this stuff, and they have basically a server, a data collaborative server, you can think of it as an RDF store, that lets you, and then the second thing is you let the user, use the filtering and other kind of features that you can do because you know the structure of the information to, quote, draw a picture of what they want, and then you fill in the picture with the appropriate data. Duh. Now, how do we get the data exposed? Okay, well, they have plugins. Here's an example of the plugin for Excel. What you do is then you associate things on the right, models, with the columns in the spreadsheet. And, if you didn't have one, you could create one on the fly and so on, and build up the model. And if you have a different source, you do kind of the same process. Select a description that gives you your data set, and you can repeat the process and so on. Now, having done this, you now have these different data sources, and you can pick which ones you want, and you can work with it on what they call ANSO for the web, which is to say anything you can see on your desktop, you can also see on the web. And plus, you can use these various kinds of filters, various lenses, that allow various views. In this case, we have, 3 of them that are set up, but there'd be a library, there's actually a library of quite many, many, many more. And this first example is a scatter graph of kind of showing you frequencies. This, of course, we saw this guy before, and these guys before, but they're all different views off the same data set. If I go back, to where we were with what set of data. There's the data set of data, and then, any of those, visualizations can be pulled off of it. We can also, combine and filter. You sort of have a list view. You notice we have multiple sources and agencies. We want to make, filters out of that, and so we click and we can, constrain it. So I want to, it's like saying, I want to know, all the, I want to know states that created more than one job due to such and such a program, at such and such a funding level. So, in other words, I can concatenate things. Those of you, anybody who's done Boolean kind of searches and so on, SQL type searching, this is not, this is not like new ground. But what it is new ground is that I didn't have to build a warehouse, and if I changed, added more data to it, I didn't have to rebuild it again. In other words, what I'm doing is getting all the power of what I would get out of SQL with, but being able to, do that over this fabric of that links all these different sets and explains how they're interconnected with each other. And in fact, I even get a more flexible arrangement than I would with a typical, optimized data thing. So we can apply and we can filter, narrow things down. We can use the ontology to guide as we explore relationships. We can have, and as we do this, the new data that we're combining and matching and putting together is always available. And, and you can click and add things to this and create a new filter. And then, that further narrows things down and so on. And they say the possibilities are endless, but, they're least significant. Okay, so I ran a little long, sorry, but I had fun. And that's what you're supposed to do when you come to a meetup. So anyway, the call to action here is, hey, it's our time. It's our time. Semantic technology folks, it's our time, to demonstrate citizen-friendly semantic solutions for recovery.gov and data.gov. And we're working on it, and we're, looking forward to working with you guys as well.